Well, this is called magic, we're learning this together as magical. Let's do question 18. In question 18, you have a log of mass, basically diagram size. You have a motor or pulley which is connected to a log. And the log has a weight of a mass of 450 kilograms. Pulled up a slope by wire attached to a motor, or this is a motor. This is a log, shown in figure 18. The angle, the slope at the horizontal is 12 degrees. Frictional force acting on the log is 650 newtons, so it's pulled up, so the log is moving up. So friction here is equal to 650 newtons, opposite direction to its movement because it's going up. The log travels with constant velocity. Keyword constant velocity. With reference to the motion of log, whether the log is in equilibrium. Again, to a question, what do I say? Quite easy for answer. For log to be in equilibrium, A, no resultant force in any direction. B, no resultant torque in any direction. When you have constant velocity, what can you say is true about acceleration? Acceleration equals 0. If acceleration is equal to 0, what can you say is true about resultant force, which depends on mass and acceleration, equal to 0. Hence, there is no resultant force. Okay. B, no resultant torque in direction. It's not rotating, so therefore it is not. Therefore, it is not moving or rotating. So, in this case, there's nothing about rotation, there's only constant velocity. So we need to add a line here. No resultant force in any direction, since log is moving in constant velocity. So now, goes back to the previous video. I was like, wait a minute, but the log is moving. So how can it be in equilibrium? How can it be at rest? How can it be stationary? Look here, means we have to refine our knowledge again. Perhaps in equilibrium, you can have a moving object. Notice here, this is a moving object. But it's still equilibrium because there's no resultant force. So what is equilibrium? Is it truly stationary? As mentioned in the previous video. With this question, you notice, no, equilibrium, two important things. Resultant force must be 0. But if you remember Newton's first law, what is Newton's first law? An object is either at rest or at constant velocity unless acted by external force. That means when there is no force, an object can be two states, according to Newton's first law. It can be in one or two states. It can either be A at rest or B in constant motion. So now we know something extra. That's why it's always good to go through past paper questions. You can learn more, you can understand more. So equilibrium. Wait a minute, it's not about stationary now. It's about, it can be moving. Also due to Newton's first law. It's just that you must check there's no resultant force. That means it's not accelerating. Here, quite obvious, there's no resultant torque, so we just leave it as it is, and then you can answer the question. So, I hope you understand this video. If not, please replay this video